Hi, this is the video for notes for week 2, day 1, and this is on pages 4 through 8 of our guided notes in Math 38. So we're going to start talking about the different kinds of numbers that we're going to be interacting with this semester, and some other things about value and order. And then we'll get into adding and subtracting integers, which hopefully all of this should be review, and it will not be too taxing for you. So the first thing here is that the integers, which we're going to be looking at the most this section, is the set of whole numbers and their opposites. So if you look at this, this is typically how you will see it, in set notation. And you'll see that we've got 0, we've got 1, 2, 3, and so on. And then we've got the -1, -2, -3, and so on. So we have both the positives and their opposites. Now, integers are part of the set of real numbers. And we're only going to be dealing with real numbers in this class. You may have seen imaginary numbers or complex numbers in a different class. So real numbers are anything that do not have an I in them. So I'm going to just put a few notations here and there. So real numbers, no I, which is the symbol for the imaginary numbers. As far as anything else, it's going to be part of this set of real numbers. And then we've got some other sets in here. The rational numbers and the irrational numbers are separate sets, but then the ones that are underneath the rational numbers, integers, whole numbers, and natural numbers, which means that if something is a natural number, it can also be classified as a whole number. It's an integer, it's a rational number, and it's a real number. It's just not an irrational number because there's no overlap between those. So the natural numbers, I will sometimes call those counting numbers. You'll see that in other books too. You just think about counting. When we count spaces on a board game, you always start with 1. So the natural numbers are going to be 1, 2, 3, 4, and so on, out to infinity. Whole numbers are going to be those values plus one additional one. So these two sets are the closest to one another as far as being similar because they add the 0. They don't have anything else. There's only one number difference between these two sets. So whole numbers include the whole. Sometimes people do that to remember them. Integers, as we just were looking at up above, so the whole numbers and their opposites. So here we're going to be going off to infinity in both directions. So off into positive infinity and negative infinity. And you may see this symbol, a Z with a double stem, as the symbol for the integers. And if you go over here to the real numbers, often you will see an R with a double stem as the symbol for the real numbers. Okay, rational numbers are ones that are able to be written as a ratio. That's where the rational comes from. So we're not talking about, people who are not in their right mind sort of thing. So rational numbers can be written as a ratio. Now, so anything where I can have like A over B, where A and B are both integers, so members of this set of integers. And those things in rational numbers, so there's a lot of them in here, so you can, just as long as you can write it as a ratio. But some examples of that would be like 3.5. So a mixed number could be written as a ratio. negative 0.5. We know that we could write this as negative 1/2, or negative 10 over 20, or negative 50 over 100. All of those things would give us negative 0.5 as a decimal, so it can be written as a rational number. Things like 212 1/3, and so on. So anything where I can have a ratio of integers for my number. Then we have this other set over here, which does not have the overlap, that is set of irrational numbers. And irrational numbers are different from rational numbers in that they have a decimal that does not repeat, not an R in there, repeat or terminate. So these are numbers that are in decimal, when they are in decimal form, do not stop ever, and they also don't repeat. There's no pattern that we can find. And examples of that, the big one that you guys have seen before is pi, which we know is, approximately 3.1415926, blah, blah, blah. But it doesn't stop, and it goes on forever. Another one that would fall in there is like square root of 2. So if you have a square root of a number that is not a perfect square, that's going to be 1.41 and so on. And it will continue on and will not repeat. So that is part of the definition. And I guess you could kind of say they're irrational because they're a little crazy because they don't stop and they don't repeat. But there is no intersection between the irrational numbers and the rational numbers. But both of those together are part of the umbrella of the real numbers. And hopefully this will give you a little bit of an idea of how those different number groups fit together, because we will be referring to them off and on as we go through the semester. All right, a little reminder about symbols of order, that this one would be, if I was reading it, would be less than. This one would be less than or equal, because notice it has a part of an equal sign there. So it's not just the less than, it's less than or equal. When I have the arrow going the other direction, that is going to be greater than. And then this one that has the portion of the equal sign would be then greater than or equal. And I don't, I don't worry about what one is. No, we'll skip that for right now. We'll get back to that. Okay, so the next part there is just a reminder, because this is one of those things where it doesn't always occur to one right away when you see it. But if I'm saying A is less than 0, then that forces that number to be negative. Okay, so A is negative if it is less than 0. If A is greater than 0, then we're going to have A being positive. So just another way to kind of get what is the implication of A being greater than 0? Well, that means it's got to be something to the right of 0, and it's only positive numbers to the right of 0, so A has to be positive. The next little bit here we're going to do is a review of absolute value. And absolute value is how far away you are from 0. And when we are working with absolute value in terms of order of operations, we are going to put that in with the parentheses. So if there's anything inside those absolute value symbols, you've got to do that before you actually take the absolute value, because we're going to have those put in with all of those brackets and parentheses and anything that is telling us that this thing inside of here has to be done first. Absolute value is always equal to either 0 or a positive value, because we could be right at 0 or we can be a distance away from it. Now, as far as this next bit here, we'll look at our number line here a little bit. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so there's a little scale on my number line here. So every tick mark, you show one of those little vertical marks is called a tick mark, and those are moving me one space each time. So thinking about absolute value. So if absolute value of 7, all right, so you're thinking about, okay, well, where is 7? 7 is going to be over here. And you want to figure out how far away from 0 are you. Well, start at 0. 1, 2, 3, 4, 5, 6, 7. So the absolute value for 7 is 7. The next one, we're looking at -7. So if I look at -7 on my number line here, it'd be about there. There we go, -7. And again, I'm looking for what is my distance away from 0. So 1, 2, 3, 4, 5, 6, 7. It is also 7 spots away from 0. But notice it's positive because we're looking at just how many steps away from 0 are we. And we're always going to have that be a positive value. Now, if I'm given 0 itself, I'm already here. I'm at 0. So I am 0 away from 0. So my distance is 0. So my absolute value will always either be a positive value or 0 itself, if that's the value I'm starting with. When I look at my number line here, we've got the 0 in the center, and then we're going off to positive infinity this direction, and then we go off to negative infinity in that direction. As far as the value of these numbers, so we've got actual value. So actual value is going to get increases as we go to the right, and decreases as we go to the left. Absolute value is a little bit different because it is the smallest here at 0. So absolute value is the smallest here and gets large no matter which way you go. So absolute value increases as you go to the left or the right. So for absolute value, the ends are higher than the center. Whereas in terms of actual value, this is just going to go up, and then we just go down when we are going to the left. And it's important to understand the difference between those two, because this idea of absolute value is what is going to help us when we are adding and subtracting those integer values. So just again, thinking about actual value, think about this in terms of money. If you have $100, that's going to be bigger than negative $100. Negative $100 is going to be, you owe somebody else $100. So that's going to be down here. But positive 100 values would be up here. But both of those would have an absolute value of 100. Okay. Let's flip to the next page here. And page